back to another Miss Pollard YouTube video. Today we're going to be looking at parallel and perpendicular lines. So first we're going to see what makes lines parallel and perpendicular to each other, but also how to create those equations of a parallel or perpendicular line when given a line and a point. So let's go over what parallel and perpendicular means. So first we're going to take a look at parallel lines. So what happens for a line to be parallel to another line? We have to look at their slopes. So if their slopes are the same, the lines are parallel. But also if we can look at a graph and see if their slopes are the same by counting how many goes up, how many goes over, and making sure those are the same rise over run. But also if we are given an equation, make sure it's in slope-intercept forms and look at their slopes to see if they're the same. Let's take a look at this question here. So this question says, what would be the slope of a line that's parallel to y equals 5x plus 4? Well, we just said for lines to be parallel to each other, they have to have the same slope. This is where it becomes important to see what is the slope of this equation. We have to remember our equation y equals mx plus b. Well, our m here is 5, so for our slopes to be the same, our parallel slope would have to be 5 as well. So our slope of our parallel equation is going to be 5 as well. Let's see what perpendicular means. So for perpendicular, what do we see has to occur? For lines to be perpendicular to each other, they have to have negative reciprocal slopes. And sometimes that word is a little bit confusing. What does negative reciprocal mean? Negative reciprocal means we flip the fraction we're given and change the sign of that fraction. If we're looking at this graphically, this means that our two lines are intersecting, but it's very important to note that they are intersecting at a right angle. They're not just intersecting at any certain point. They're intersecting and creating a right angle for them to be perpendicular. So let's see what type of question is being asked. So it said, what would be the slope of a line perpendicular to y equals negative 2/3 x plus 5? First step, look at the slope. This is in slope-intercept form already, so we just look at the slope. They gave us negative 2/3. To do the negative reciprocal of it, we're going to make it positive and then flip this fraction. So the slope would have to be flipped 3/2. It was negative, we're now making it positive. So that is how we're going to use these equations to see what their slopes will be. Let's try a practice problem where we can find the whole equation of a line parallel or perpendicular to one given. So we want to write an equation through this point parallel to this line in slope-intercept form. So like I said, our first step every single time is to determine the slope. Thankfully, this is already given in slope-intercept form, so I'm just going to look at it and say
my slope is negative 1/4, so my m is negative 1/4.
It's asking for into slope-intercept form. So there's two ways we can go about this, and you may have seen this in my other videos, where we can go from point slope form to slope-intercept form, or we can just go from our regular slope-intercept form, and there we go. So I'm going to do it from slope-intercept form to slope-intercept form, but if you want to start off with point slope and keep going, that's perfectly fine.
So my slope is negative 1/4, so I'm going to write y equals negative 1/4 x plus b.
So we're trying to find our y-intercept. We don't know what it is. It's not the same equation, because if I plug in negative 3/3, it does not have an equal balanced sides. So that means negative 3/3 is not part of that line. We need to find what our b would be. So I plug in 3 as my y, negative 3 as my x, plus our b. Negative 3 times negative 1/4 is 3/4. I like to tell my students, let's try to get this number in fourths. Let's try to have it as a denominator 4, so when I move over, it's easier to add and subtract. My students sometimes struggle with doing 3 minus 3/4. It's easier to transform this into a fraction and combine our like terms. So 3 is the same thing as saying 12/4. So if I subtract 3/4 from it, we get b as our 9/4.
So my final equation in slope-intercept form is going to be y equals negative 1/4 x plus 9/4.
Every time, find the slope. See if we're talking about parallel perpendicular line. Plug in our point, and we have our new equation. Let's see a problem where we're going to be using perpendicular slope instead. So now we have a problem that's asking for the perpendicular line, and we want to put it in standard form. So we have our slope, it's already in slope-intercept form. Our slope is 2. So we need to take the negative reciprocal of that. So 2 is the same thing as 2 over 1. We flip that, that becomes 1 over 2. Because it's positive, we make it a negative. So my new slope is going to be negative 1/2. I'm going to plug it into y equals negative 1/2 x plus b. And I'm going to plug this point in. So my y is negative 2. My x is 1. And we're solving for our b. Negative 2 is the same thing as negative 4/2. Just put it in halves. This becomes negative 1/2 plus b. Add the 1/2 over. I get negative 3/2 as my b. So my equation in slope-intercept form is going to be y equals negative 1/2 x minus 3/2. But I am not asking for it in slope-intercept form. I'm asking for it in standard form. So we need to use our techniques we learned when creating equations to put this into standard form. So I add 1/2 x over. So you want both your x and y on one side. And you cannot have fractions in standard form, so I'm going to multiply everything by 2 to get rid of that fraction, and I get x plus 2y equals negative 3. So this is a perfect example to see how we would create a perpendicular equation given a line and a point. Let's try another problem. Now we have this problem where it's asking to find an equation in slope-intercept form through this point that's perpendicular to this equation. Number one step, always, is to find the slope and then determine what we have to do with it to see if it's perpendicular. So we are going to have to put this in slope-intercept form. Sometimes people think, oh, our slope is negative 5. It's whatever is in front of the x. No, because our y has a coefficient, that is not our slope. So we need to get this into slope-intercept form so we're able to properly complete this problem. So I'm going to add 5x to both sides. I get 2y equals 5x plus 2. We still don't have the y by itself. Slope-intercept form needs to have the y by itself. So I divide everything by 2. And I get y equals 5/2 x plus 1. Good, now we have it in slope-intercept form. So we see that our slope here is 5/2, but we're trying to find something perpendicular, which means we flip it, so it becomes 2/5. Because it's positive, we make it a negative. So we have our slope as negative 2/5. Plug this point in. So y now is negative 5 equals negative 2/5 times 4 plus b. This becomes negative 8/5 over here. This in fifths becomes negative 25/5 plus our b. Now we're going to add 8/5 over. And we get negative 17/5 equals our b. And we can write that as y equals negative 2/5 x minus 17/5. They didn't ask you to put into standard form, so we can just stop here. So this problem is here really to show you that if the equation is given to you in standard form, you must always put it into slope-intercept form. I'm going to give you questions asking, is this parallel to this equation? And you're going to have to know that I have to put it in slope-intercept form first to be able to determine if they are parallel perpendicular. If there is a number, a coefficient in front of your y, you cannot see what the slope is. You have to keep moving and find the slope. Now let's try this problem that's a little bit of a step it up. So now instead I'm asking for you to give me the equation of the line parallel to it, and the equation of the line perpendicular to it. I'm just going to put everything into slope-intercept form. I might ask you on a quiz or homework to put it into standard form, but I know by now we are masters at that, so we are just going to put it all through slope-intercept form so you can see the steps and then step it up that little notch if you need to. So we are going to find the equation of this line first. So we have 4 minus negative 16. Always find the slope. Negative 7 minus 5. So this gives me 16 plus 4 is 20. 7 minus 5, 12, negative 12. So now we have to simplify that though. That's not a proper fraction simplified. So I'm going to divide by 4 and I get negative 5/3 as my slope. So we have our slope. We now have to create our original equation. So I have y equals negative 5/3 x plus our b. I need to plug in one of my points to solve for my b. So I'm going to choose the negative 7/4 because why not? So I get 4 equals negative 5/3 times negative 7 plus b. This in thirds becomes 12/3 equals 35/3 plus b. I need to get the b alone, so I subtract 35/3 and I get negative 23/3. So my original equation is y equals negative 5/3 x minus 23/3. And I will box that off. Now that I have that equation though, I need to find the parallel and perpendicular. I like to start with parallel because it's the same slope. So if I look at this slope, this is negative 5/3. What's important is if I messed up here, my whole problem's going to be wrong. Obviously, there's chances for partial credit. However, we don't want to mess the whole problem up. So let's make sure we're doing our slope right so we can continue properly. So my parallel, that's the symbol for parallel, slope is going to be negative 5/3. It's going to be through here. So y is negative 1 equals negative 5/3 times 6 plus b. Negative 1 equals negative 10 plus b. So my b becomes 9. When I add that 10 over, I get b as 9. So my parallel equation is y equals negative 5/3 x plus a 9. So thankfully it worked out nice. When I plugged in my x term, it no longer had a fraction. I plug in to solve for my b. Let's see how we would do this perpendicular. I'm going to erase over here. So our regular slope was negative 5/3. I want my perpendicular, which means we flip it. We have negative 5/3, we flip it, which becomes 3/5. Because it was a negative, it becomes a positive. So I have y equals 3/5 x plus b. Plug in 6 negative 1. Negative 1 equals 3/5 times our 6 plus our b. In fives, this is negative 5/5 equals 18/5 plus b. Subtract 18 over, we get negative 23/5 plus b. So our perpendicular equation is y equals 3/5 x minus 23/5. Once again, I could ask you to put this into standard form. I just wanted to show you the process to make sure we're all on the same page. Create the normal equation, write that down. Obviously, we wouldn't erase it if we were doing a quiz or classwork, but we'll want to make sure I had enough room. Parallel gives me the same slope. Perpendicular gives me negative reciprocals. I flip that. Let's try one more problem to make sure we're all on the same page. Now we have this problem, like always, our first step is to find the slope. So I got negative 10 minus a negative 1 gives me negative 9 over 3 minus 3 gives me 0. If I have negative 9 divided by 0, put that in my calculator, I get an undefined slope. That doesn't mean we can't continue the problem. A lot of people think, oh, undefined, I'm done. No, undefined slope is a vertical line. A vertical line has an equation of x equals a certain number. Well, let's look. Well, what are the x values the same here? 3. So our equation of our original line is x equals 3. Now, we want to find an equation of a line parallel and perpendicular to that. Well, parallel, for them to never touch, it would have to be another vertical line. And the vertical line would have to go through 9. So we get x equals 9 would be my parallel line. My perpendicular line, a line that will create a 90-degree angle that we discussed before, is a horizontal line. See these 90-degree angles? So a horizontal line has an equation of y equals a certain number. So our y in this point I give you is -8. So anytime we get an undefined or zero slope, we need to remember, is that an x or y equation? Once we get that, parallel will be x equals the same type for parallel. If it was y equals a number, it'd be the same type, y equals a number for parallel. If it's x equals a number, our perpendicular is going to be y, and vice versa. If it's y equals, this will be x equals. So hopefully these problems were helpful for determining how to create equations of parallel and perpendicular lines.